Good morning, everybody. So we will continue our topic relation function and binary operation part 3. Already we have done 2 sessions on this. Today we will start this part 3 on this same chapter. Let's see. Last class we had finished the types of relation. All the types of relation we had finished. What is a relation? Now we will start a special type of a relation that is called the function. We will see the types of functions. The function chapter is being studied in 11th grade. Just I'll give the little overview. Suppose there are two sets A and B, and here we have some elements, and in B we have some elements. And suppose there is a rule, a function is defined from A to B. Suppose this is 1, 2, 3, 4, and here we have A, B, C, D, E. Suppose one is related to A. The relation in which a relation is called a function if every pre-image will have only one unique image in A, and all the elements in A should be connected. So 2 is also connected to A, 3 is also connected to B, 4 is also connected to C. So this relation here is a function. Here this set A is called domain. So here the domain of this function is 1, 2, 3, 4. The range of this function is A, B, C, only connected one. And codomain of the function is all these sets A, B, C, D, E. That is our codomain. So this any relation of this kind is called the function. Now we will see here basically the types of functions. Let's see that. Let's see the types of functions. In types of function, basically we will see 4 types of functions: one function, onto function, many one, into function. Let's start first with one function. One function, and here only I will write many one function. See, what is this one function? Suppose we have two set A and B, and a function is defined from A to B. Here we have some elements, here we have some elements. Suppose a function is defining from A to B such that the element in A has image only one here, and that too unique only. Means for 2 elements you will not have as one image. That is, suppose A is connected to B, this is connected, suppose this is 1, 2, 3, this is A, B, C, D, 3 is connected to C, this is one function. Why? Because 1 has image 1 A, 2 has B, 3 has C, different. Now let's see what is many one function. Suppose we have two set A and B, a function is being defined. Here we have some elements, and here we have now see, suppose 1 has image A, 2 has also A, 3 as B, 4 as C. Now see, if you see here 1 and 2 both in the domain are having the same image here as A. Hence, this is many one function. That's why we name it as one and many one function. Let's see what will be the condition for this. See the graph also. What is the graph? Suppose the function of many one function will be like this. If you take any horizontal line, okay, if you take any horizontal line, suppose this is the function y equals to fx. If you take any horizontal line that should cut the graph at only one point. Suppose this is the horizontal point, it is cutting here. Suppose this is the horizontal, it is cutting here. Suppose this is the horizontal, it is cutting here. This is our x and y axis. This is horizontal. So how many horizontal lines you will take? It will cut at only one point. So it will be the one function. Now let's see what will happen in the many one function. Suppose we have a function like that, y equals to fx. So if you take any horizontal line that will cut the graph more than one point. For example, suppose this is our horizontal. This is x, this is y. This is horizontal. Now see, if this horizontal line is cutting here 1, 2, 3, 4, what does it mean? See, what does it mean? Suppose this is A, this is B, this is C, and this is D. It means the image of, and this line is y equals to C because it is parallel to x-axis. So A, B, C, D all are having the same, suppose this is C dash. All four are having the same image as C dash. Hence, obviously, this function will be many one function. Let's see the more examples on it, and also how to find the one function. See how to find any function is one or many one. For x1 not equals to x2, if you are getting fx1 equals to fx2, then what will happen? This function will become many one, because x1 not equals to x2, we will get fx1 equals to fx2. So this will become many one. Okay. Otherwise, 1, right? Otherwise, 1 function. Now let's see the problems based on it. The question is, first question, a function is given fx, a function f is there from real to real such that fx equals to x squared. We have to check whether this function is one word or many one. Let's see. We will see by first method. By theory method, okay? Let x1 not equals to x2 and f of x1 we will get f of x2. We are assuming this. Now put this value in this function fx equals to x squared. So f of x1 will be x1 squared equals to x2 squared. So from here we are getting x1 equals to plus minus x2. That is, we are getting x1 equals to x2 and x1 also we are getting minus x2. Right? What does it mean? what we have assumed that x1 not equals to x2, this is being satisfied here. Hence, we can say that this function is many-one function. Many-one function. This is by the theory method. Let's see the next method, second method. This we will solve by using the example methods, by observation. F of 1 equals to 1 square, that is 1. F of minus 1 equals to minus 1 square, that is 1. So we are getting 1 and minus 1. 1 and minus 1 are having the same image as 1. So obviously it will be many-one function, right? So this is by observation, this is by theory. Let's see other method, that is by graph method. See, we know this is our x-axis, y-axis. We know that this graph will be a parabola passing through the origin, and the graph will be like this, y equals to x square. Now, what I taught, if you take any horizontal line, see here it is cutting, here also it is cutting. Hence, if you take any horizontal line, it is cutting here, this and this place. So obviously it will be the many-one function, right? That is the thing. So I have solved a single question by 3 methods. Any method will be applied at a proper, means if the question are having different easy graph, then we can use the graph or theory or this, anything we can use. Let's see the next question. Suppose the question is fx equals to x by 1 plus x. We have to decide whether this is 1, 1 or check for 1, 1 or many-one. Let's check it. Let for x1 not equals to x2, we are getting f of x1 is equals to f of x2. Now put this value here, so we will get x1 by 1 plus x1 equals to x2 by 1 plus x2. Cross multiply it, we will get x1 plus x1 x2 equals to x2 plus x1 x2. So what we are getting? We are getting this expression after cross multiplying. Now this and this factor will get cancelled and we will get x1 equals to x2. What we have assumed, x1 not equals to x2, and what we are getting, x1 equals to x2 only. That contradicts, means what we have assumed, that is wrong. So this function won't be many-one, so it will have to be one function only. So this is one function. Let's see the next. Now other type of function we have onto function and into function. Onto function and into function. See, what is it? Suppose we have two functions. One function, suppose we have y equals to fx, which is defined from, f is defined from a to b. So here suppose the range of this function is b1. Suppose the range of this function is b1, and from here we can see what is the codomain of this function, b. If b1 becomes b, then we say fx is onto function. Then fx will be our onto function. If the range will be equal to codomain of the function, we say it as onto function. And just the reverse of it, if b1 not equals to b, that is b1 you can say a proper subset of b, then fx is into function. Okay. Now see by the graph. Suppose, for example, suppose fx is a function fx equals to x. The graph of y equals to x is like that. This is our x-axis, y-axis, origin. Now, what is the range of this function? The range of this function is all reals. What is the codomain of this function? All real. Codomain means range will keep on going down towards, that is minus infinity, and will keep on going up, that is plus infinity. So range is also real, domain is also real. Hence this function fx equals to x is onto function. Let's see the into function graph. Suppose we have graph y equals to x square. A function we have y equals to x square. Now what is the range of this function? If we see, the range of this function is from 0 to infinity, because the value of x square can't go below the x-axis, right? And what is the codomain? What is the codomain of this function? That will be all reals. If nothing is given, we consider the codomain as the all reals. So that will be like this. Okay, so obviously it is into function, right? So we have it as into function. We can make any into function into onto function. Now let's see. Suppose I am defining a function fx as equals to x square such that the function is 0 to infinity to 0 to infinity. Suppose any function is defined like this, fx equals to x square, where it is being defined from 0 to infinity to 0 to infinity. Now this is codomain of the function, as well as the domain of range of this function will be all positive. Here in this case, in this function, I have applied some constraint on the function, and that into function has been converted into the onto function. So by putting some constraint, we can convert our into function into the onto function. So this here is the onto function under this constraint. Okay, let's see more examples on it. Now I will give the question, and we will have to decide whether this is one, many, onto, into, all these things. Check for 1, many, into, onto function. The first function I am taking fx equals to x cube. Suppose we have this. Now see. See, if we are taking fx equals to x cube, then see, let's see the graph of it. The x cube graph is like that, right? This is, it will keep on going up, it will keep on going down. This is the graph of y equals to x cube. Okay. Now see, take any horizontal line here, cutting at one point, cutting at one point, cutting at one point, cutting at one point. So what is this? This will become 1 function, right? Now see, the codomain of this function is all reals. Now see the range. Range is, it is keep on going, right? That is towards minus infinity, and it will keep on going up, that is towards plus infinity. Hence the range is also all reals, codomain is also all reals. So this function will be onto function. Any function which is 1 onto, that is called bijective function. Okay? Any function which is 1 as well as onto, that is called the bijective function. So this y equals to x cube is a bijective function. Okay? Let's see the next example. The next question we can take. Let's see. Fx equals to x squared, and this function is defined as from natural to natural. Okay? Fx equals to x squared is a function, and here the domain is all natural numbers and the range is also belongs to natural only. We have to decide whether this function is 1 minus 1 into or onto. Let's see. See, let x1, for x1 not equals to x2, we are getting f of x1 is equals to f of x2. Okay. Now see, put the values, we will get x1 squared equals to x2 squared. So x1 we will get either x2 or x1 we will get minus x2. Now see here very carefully. Although we are getting two values, but here it is given the domain is all natural numbers only. What are natural numbers? Natural numbers contain all the sets 1, 2, 3, 4 like that, right? So here x1 equals to x2, okay, x1 equals to x2, 1, 1, it will be equal. But for x1 equals to minus x2, here we have a problem. Because x1 and x2 are the naturals, so negative of natural, we will get the negative number. So actually it is negative number. And any natural number can't be negative. Hence this case will be rejected. So what we are getting? Only we are getting x1 equals to x2. So what we had assumed? We had assumed x1 not equals to x2, we are getting x1 equal to x2. Hence we are getting a contradiction, hence f is 1 function under the condition given in the question. Hence f is 1 function. Now let's check for x into or onto. See. What will be the range of this function? First, codomain. What will be the codomain of this function? Codomain will be all natural numbers 1, 2, 3, 4, 5, 6 as it is given. What will be the range of this function? The range will be all x square type. Put x equals to 1, 1. all square numbers, 4, 9, 16, 25, like that, all square numbers. Do we have 2 in the range? No. 2 is there in the codomain, but it is not there in the range. Hence, here range of y is a proper subset of natural numbers, that is codomain. Hence, this is into function. It is into function. So, this function is, so we can say f is 1, 1 into function. 1, 1 into function. Okay, that's the thing. Now we can see it graphically also. The second method I am telling. Suppose this is the graph of y equals to x squared. But here we have to take only the natural numbers. So suppose here we have 1, 2, 3, 4, 5. So here it will be this. Only the dotted plotted points will be the graph. Only the dotted, this first dot will be the graph. Graph will be dot wise. Now see, for 1 only, this is not natural, so we will not consider it. So 1, we are getting 1, 2, 1 image, 3, 1 image. So this is 1, 1. Also, suppose here we have 2. So 2 will correspond to root 2, but root 2 is not there in the domain. So all the range does not belongs to codomain, hence it is into function, right? It is into function. So that is there in the 1, 1 onto function, 1, 1 into function, many one. These are the types of the functions. Okay. So we had seen now the types of function, what is 1, 1 function, what is many one function, what is onto function, what is into function, how to derive it also we had seen. We will, this is by theory, that is by graph, and we can have observation also. But observation will not work always. This will work always. If this depends on the question, what question we have, and depending on that, either if the graph is easy to draw, we will draw the graph. If it is easy to solve by theory, we will solve it by theory only. Okay. So this is all about the types of function. Next class, we will see more about the function. Okay. Thank you very much.